You might be wondering why I am going to talk about retirement a fair amount during this course. Discussing retirement is appropriate for a personal investing course because you're going to be investing the money you're saving for retirement, and you can invest it in a huge variety of different types of financial assets. While I'm discussing different types of financial assets, I'll talk about the potential return that you can earn, the risk you'll potentially be taking, and how that applies to people saving for retirement at different stages in their life. And by stages, I really mean different ages, but I could also refer to it as the stage while you're raising children. And many people don't start saving for retirement until after their children have grown, and then they discover they need to catch up, and it's very difficult to do that. So, what I want to demonstrate in this video is the impact of beginning to save for retirement when you're fairly young. Let's say the traditional series of events is that you start working when you're in your early 20s, you work for 40 years, and then you retire around the age of 65. What I want to do is show you how each deposit that you make into your retirement account impacts your retirement balance the age you retire. I could do this on a monthly basis, but it's just a lot quicker and easier to show you if I just do it on a yearly basis. So that's what I'm going to do, but the same process would work if I were doing it on a monthly basis. Most people, when they put aside money from every paycheck, they actually do it every 2 weeks, not even on a monthly basis, but more frequently than that. And I'm going to make a couple of assumptions. First is that you get a raise every year of 3%. And secondly, that you can earn a rate of return on average per year of about 8%. Now, to earn 8%, you're going to have to invest your money in risky stocks. But if you begin saving for retirement when you're in your 20s or even sooner, then you can afford to invest in risky stocks. I think over here I'll put a salary, and I'll just put 40,000. And then I'm also going to put the percent that you save every year. So, like in my case, I save 10% specifically to my 403b, which is my retirement account. And then Western matches me 10%. So essentially 20% of my earnings every year are going into my retirement account. I'll do 15%. I'm going to post this spreadsheet though so you can put in your own numbers. And you'll just need to change these numbers, and I'm going to design the spreadsheet so it automatically updates. What I want to do then is, for the very first year, and I'm saying you're only making deposits once a year, not even once a month or every 2 weeks, just once a year, and it's happening at the end of the year. So the first year, you're going to take this salary, multiply it by the amount that you're going to save. So your first year, you're going to put aside $6,000. The second year, though, it'll be 6,000 times this raise amount. And I'm going to make this raise amount of 3% of what they call an absolute reference. So when I copy this formula down, it'll always take the previous year's amount and increase it by 3%. And actually, technically, I need to multiply by 1 plus that 3% because I'll actually show you why. If I just put 6,000 times 3%, it's only counting the increase that's going to happen from year 2 versus the previous year. But I want it to also include the original 6,000 because I'm going to be making 40,000 times 1 plus 40,000 plus an additional 3%. So 15% of 40,000 plus that additional 3% is going to be 6,180. So not only am I going to save an extra $180 in year 2, I'm also going to save 6,000. The way to deal with that is just take that increase, the raise, and add 1 to it. I can now drag this down, and it's going to automatically adjust for the raises I'm receiving. And I also just want to format that as the dollar amount. And I don't really care about the decimals. So this person, I don't know if for the career you're planning, if 40,000 will be too low or too high of a number for you. So you'll need to adjust your own numbers. Adjust this so it reflects your own values. The next thing I want to do is pull everything to the end of year 40. And I'm going to start doing this in year 40 and then go backwards, because I think it'll make a little more sense to you. I could use a financial calculator to do this, but Excel has a financial calculator built into it through a series of different functions. This is the future value function. So what I want to do is tell it to pull this value that's going to be deposited at the end of year 40 to the end of year 40. Well, it's already at the end of year 40, so it shouldn't change in value because I specifically said the deposits made in column B occur at the end of the year. And since it's the 40th year, it's already the end of year 40. But I want to create a formula here that I can drag up. So I need to input the rate of return that it's expected to earn, and that's this interest rate. The rate of return on the investments that I'm depositing this money into. I always want it to refer to F2 for that rate, so I need to make it an absolute reference. And I did that by pressing the function key F4, and it put those dollar signs in front of it. Now the number of periods that I want it to pull this value forward will be a fixed number of 40, which I'm making an absolute reference, minus whatever the current year is when I apply this formula. Well, for row 41, the current year is also year 40. I'm doing an absolute or fixed reference to 40. Minus 40 will give me 0. So I'm not going to pull this number forward any years, which is exactly what I want. But when I copy this formula to year 39, it's going to take this fixed value of 40 minus 39, which will give it 1 year. And so the second to last deposit will be pulled forward 1 year by the rate that's in cell F2, which is 8%. And that's exactly what I want. There's no payment. You don't necessarily need to enter a value here. I could enter a 0, or I could just enter another comma, and Excel will automatically note that I didn't put a number between those two commas, and it'll assume a value of 0 for the payment. And then the present value, Excel will always return a value of the opposite sign as the number that I enter as the present value. Since this is positive, it'll actually return a negative value when I press enter if I click on that and I don't change the sign. I don't want it to return a negative value though. I want it to return a positive value, so I'm going to put a minus sign in front of that. So this is exactly what I expected. It didn't pull the $19,002 forward any years, so it still got a value of $19,002. But when I copy it down, it's pulling this $18,449 forward 1 year at a rate of 8%, which is in F2. And now I'm going to pull all of this back to the first year. What this means is the $6,000 that I deposit in year 1, after being invested for essentially 39 years, it will be worth $120,691. This $6,180, even though it was $180 more than the previous year's deposit, will be worth only $115,104 in year 40. It'll be worth about $5,000 less than the $6,000 that I deposited a year ago by the time everything gets to year 40. Even though it's a higher amount, it's worth a smaller value because it was in there 1 fewer years. And we see the same thing happening, even though in year 3, I deposited an even larger amount because it had fewer years to grow. It's only going to be worth about $110,000 by the time we get to year 40. And as we go down this list, we see the amount deposited being increased, but the value at year 40 of that amount deposited is dropping. So what I want to do is first calculate the total amount at year 40. And what I'm going to do is sum everything from C2, and remember everything in column C is at year 40, through C41, my last year. So this person would have a little over $2 million in their retirement account. But what I want to look at is how much of this $2.2 million was from the first decade. So basically from the first, for the first decade of savings, you put in, if you look down here, hopefully you can see that I've highlighted this range of years 1 through 10, and in small print here it's telling me the sum of all the amount that is highlighted. So the first decade, out of my pocket or this person's pocket, they deposited $68,783. What it ultimately grew to at the end of year 40 was $984,000. So for the first decade, I'm going to sum the value in year 40 for the first 10 deposits. So you can see that if I take this 984,000 and divide it by the 2.2 million, and I'm just going to convert this to a percentage, the first decade of savings contributed almost half of the balance that you had in your retirement account at year 40. So why am I talking about this topic to people who are in their early 20s or perhaps even their late teens? It's because you have 40 years to invest until you retire, or at least most of you do. Most of you will probably work 4 decades before you retire. Others of you might work longer, ideally because you want to, not because you have to. And some of you may wish to retire when you're 50, so you'll work a lot fewer years. But my point is, when you've got time on your side, like young people do, starting to save money when you're young is going to greatly impact your ending balance. It's contributing almost half to this person's ending balance. And I'm going to also do from the second decade. So I'm going to sum years 11 through 20. Oops, not the deposits made, but the amount at year 40. So the second decade, you actually contributed 92,000. Again, I'm looking at this number in very small print right here. You contributed 92,000, but it was only worth in year 40, 612,000. And I'm just going to do the third decade and sum years 21 through 30. Again, year 40 values, and also the fourth decade. So years 31 through 40. That's actually that worked. I hit the wrong button though. There we go. And all of these, when I highlight them all, if I look down here, they're supposed to be identical. I must have overlapped a year somewhere or messed up. Let me find my mistake. My mistake was in the third decade. I just highlighted the wrong set of years. The third decade, though, should be the sum of years 21 through 30. So I fixed it. And now when I highlight this section and look down here for the sum, it equals the sum in G7. I'm going to edit the formula in H9. I want to take the first decade's value and divide by the total. And then I want to copy this formula to the second through fourth decades, which means I want to take the second decade's value divided by the total. To make it always divide by the total, I have to make that G7 what they call a fixed or absolute reference. So now when I copy this down, if you look at the numerator, because it was not a fixed or absolute reference, instead it's what they call a relative reference, it changed it from G9 to G10 because now I'm in cell G10, but it made the divisor always G7, which is the total. So now it's expressing each of these as a percentage of the total. And you can see the amount deposited in the fourth decade only contributes 11% to the total amount saved in year 40. The amount saved in the first decade contributes in year $40 4 times as much as the amount saved in the fourth decade. And just to also give you a little more perspective, if I copy this over to the previous column, what it's going to do is, because I didn't use absolute references, it's going to use relative references and refer to the previous column relative to column C. So it's going to sum the first decade numbers for column B, which is the amount deposited. I'm going to actually highlight all 4 of these and drag them over. And that way they're all going to refer to the correct rows. So like the third decade is going to refer to column B's years 21 through 30, the third decade. This fourth one is going to refer to the fourth decade's column B, years 31 through 40. So now you can see in the first decade, in total, you out of pocket put $68,783 into your retirement account, not all at once in a series of 10 deposits of this amount, but that totals $68,783, compared to the fourth decade where you put in a total out-of-pocket expenses of about $167,000. So more than twice as much as you did in the first decade, but the first decade contributed 4 times as much to your ending wealth of $2.2 million. It contributed $984,000 versus the fourth decade savings contributing only $237,000. That is why I talk about starting to save for retirement when you're young. Time is working in your favor so much. What if you'd waited until you were 55 before you started saving money for retirement? So all these values here, I'm going to come down here. You'd start saving then, if you're 65 here, then you'd be about 55 here. So I'm going to assume that you started making 40,000 when you were 20, and then you had all those raises, and you're still going to save 15% of your money. So I'm going to actually type in, I think it was 14,139. It's a formula. It was a formula before based on the preceding year's value. So if I delete this year, it would have made an error here, which is why I hardwired the 14,000 in. But I'm going to come down here and delete all these guys. So now, if you start at age 55, saving 15% of your income, because all the raises that you've gotten over the preceding decades, that would be now about $14,139. And you'll have a retirement balance of only $267,000. So you're going to have to save a lot more to be able to survive during retirement. Let's say you want a value of $3 million here. I can use something called GoalSeek in Excel to find out how much I need to have saved each year during that last decade, but I need to make a little adjustment to this formula. So what I'm going to do is say that I started with this salary of 40,000. I'm going to use my future value again, my future value formula. So I'm earning, and I'm going to use my future value formula in an attempt to calculate how much I'm going to deposit that year. I'm earning a raise of 3% for, I shouldn't type this in, but I'm going to, and actually it would be 29 years. For 29 years, no payment. My present value will be this $40,000 starting amount. And then I'm going to take this amount and I'm going to multiply it by this 15% that I'm saving. There is that 14,139 calculated via a formula instead of me just typing it in. Now I can use this thing called GoalSeek to estimate if I really want $2.2 million here by the time I retire at year 40. So I'm going to set this value to about $2.2 million, what it was when I saved every year instead of just during the last decade. And the cell I want to change is this 15%, which is the percentage of my salary that I set aside into my retirement account every year. You can see saving only 15% got me only to $267,000 when I only saved money for, it was actually 11 years that I did instead of 10. You can see there's actually no way that I can achieve an ending balance in my retirement account of $2.2 million if I wait until I'm 55 to start saving, because I'd have to save 123% of my money. Let's go back to 15%. Maybe 15% is the absolute max that you're willing to put aside. I can use GoalSeek to solve for the interest rate that I would have to earn on my investments to achieve a $2.2 million value at the end of year 40. So again, GoalSeek, I want to set this value in G7 equal to 2,200,000. Set G7 equal to 2,200,000. Just checking to make sure I've got the right number of zeros. And the cell that I want to change now is the interest rate that I'm earning on my investments. I'm going to have to earn an annual interest rate of 47% on my 11 deposits here to get this ending balance equal to 2.2 million. That's not possible. Earning an annual rate of return of 8% is still going to be a little difficult. It might not even be possible for you to earn 8%. It's definitely impossible to earn 47% each year, even for just 11 years, much less a length longer than that. It might even turn out that $2.2 million isn't going to be enough for you to survive throughout your retirement years. Some people have 3 decades of retirement they need to finance. And for some people, 2.2 million will be enough. For others, it won't be. So one thing we'll do in this course is try to estimate how much money you'll need to set aside to achieve a livable amount to have, when you retire that should support you well enough throughout your retirement.